So Scott, here's a quick overview of the system, and then I'll run some parts for you so you can have a look. I'll go through the parts. This is the flex feeder. It'll be for the grommets, and this is you're going to control this on and off with your robot and your camera. So whenever you need to move your parts around, once your camera sees a good part, you'll be able to come down and pick, like we said. So that's pretty much it for the flex feed right there. Then behind it we have the cap feeder. These recirculate around, they come out to the end of the track. There's a sensor in the front. I'll detail that a little bit better for you as we talk more about this. This is the assembly area. The needles will come from this side. They'll be spun in front of a proc switch that's right down here, and if the proc switch sees the pulse, you'll know the needle's pointing needle end first. So then the lift will lift the needle up. If the cap is in the right direction, the lift will pick up the cap, and then the parts will be pushed together by the cylinder. This hopper over here replenishes the recirculation portion of the cap feeder. This sensor watches the table. Anytime it gets low, more parts are added automatically. And that hopper is not very big, but can easily hold a couple hundred parts. And the same is true for the needle feeder. There's a hopper for it. And same way, you can hold easily a day's production on that. And there's your recirculating bed and the sensor that tells you that you're low on parts. And the control cabinet is back here. I'll show you that a little bit better later. But let me pull apart and we can run. The sensors that detect the parts, if they're in the right position, they're in the nest, and also the hole. They're right here. It's fiber optics. They go right into the nest over here. So I'm going to pull apart and the cycle will start automatically, just as your robot would do. So you can see the cap is up because the hole is leading. Then the needle is spun. If it's in the right direction, it gets lifted and gets pressed together, and it waits for your robot to come and take the part. So your robot will probably pick up right in between here, but it could also pick up back here. And once the robot picks it up, we'll take it over to the flex feeder, and then you'll find any parts are standing up and do the insert. You have a completed part, like we talked about. So I'll run a few of these while you watch it. Now this part here failed because the needle, you can see where that part is pretty well plugged, and the needle hit the bottom. So on these parts like that, there's not much we can do with them. It's a little bit tough to find the center when it's plugged. But anyway, that's pretty much what the only fails that we get. Things like that, or if we have a lot of flashing on the back of the parts. I'm sure you're familiar with it, but like these parts are right out of the bag, and you can see that flash. So sometimes that part, as it moves up to see the sensor right over here, this photo eye is looking. If there's a hole there, then the sensor will detect that it's hole first, and it'll go ahead and lift. If it's backwards, it would see that back spot, and then it wouldn't lift it. But with a lot of flashing there, it can keep the part away from that sensor, so it can mess things up. Also, the flashing in the back can get caught when it lifts. But a lot of these will run, even though they're that bad. So it's hit and miss with that. If the parts, even if the parts are just a little bit better, like a part like that is no problem. Even though it's got flashing, the hole is, on that one, the hole is actually off center. But it typically builds those. Let me run it some more. So we just had that jam. If you notice, the system just resets and gives you a fault. You just restart it. It comes right back in. So I'll run a few here. We'll keep watching. You see the assembly. And your robot again will pick the part. And the minute the part is picked, the system automatically restarts. Now you can see that needle is backwards. Here's one coming the right way. As a spin, it's detected because it's needle end leading. Well, the cycle time is dependent on how many parts are correct when they come into the nest. So Sometimes you get a bunch in a row that are all good and your cycle time will be real short. Sometimes you might have a bunch that are backwards and then your cycle time is longer, obviously. The caps actually move quite quickly because there isn't a lot to do to test them. The needle, on the other hand, every once in a while you'll get 4 or 5 in a row that are backwards, like this one here is backwards. So then it'll take another one. There's another one that's backwards. So they'll keep cycling until you get one that's front end needle leading, and it continues to cycle. Now that one there flipped because of that little edge in the front. Now see how it just falls out? And then it'll need to be cleared. So this one had that weird tip. So that snagged on the sensor one and went up. Again, you know, we can only do so much with these parts. When you get some that are really bad like that, they're going to fail. That's why I said it might be worth your while to just do a quick pre-sort. Before loading the hopper, just go through and take the ones that are very, very bad. You know, it's easy to see them, and just put them off to the side. Like you can see that part there, that heavy flashing and that nose piece is just going to give you havoc. And in many cases, the sensor will just blow that off because they'll think it's seeing, it doesn't see the hole. So these parts will start to collect in the bowl after a while, and the majority of them will be bad. So maybe that's the way to go. Just let them, every once in a while, just go through and clear the ones that have been in the bowl for a while. So let me restart that. So these are not pre-sorted, they're just as they came out of the bag. So we're going to get, you know, you're going to see a lot of them that'll fail because of what I just spoke about. But the majority of them actually do go through and they pass. And we don't have too much further to go to push them in all the way solid. So it's worst case about a 1/4 inch, sometimes as little as 1/8 of an inch insertion, or all the way to the bottom. Now you can see where the hopper just added some parts. Now that part here has flash in the back. See how it didn't come in well? Again, that's what will happen. That one there happened to clear on its own. You can see how those caps are rejected because those holes are filled. So if your parts were just a little bit better, you could have very long runs without ever having any problems. So it's definitely going to be worth your while to see what you can do about that. But like I said, I personally would just go through and pre-sort them by eye. I know it's a little bit more handling, takes a little bit more labor, but very minimal compared to what you'll get. Because if you're, like I said, if your parts are good, they're going to run without any kind of problem. So that failed because it didn't see a needle for a while. I can extend that timer so that it doesn't do that. Let me restart it. So you can can see these needles all coming in backwards. And again, it's just random. Sometimes you get a lot of them that come in the right way, and sometimes they'll just be a bunch that are backwards. So that's going to affect your cycle time, like I said, but still be well within probably 5-10 parts per minute. You see we're having a run right there of a bunch of backward needles. Now you can see the flashing on that part is horrible, and it blew it off. So you can see how eventually, since a lot of the ones that have a lot of flashing are going to blow off, they're going to dominate that feeder bed. And you really need every once in a while just clear out the ones that are just failing all the time. So let's see, with that part, typically the holes are off center, and you can see where that's the case there. Caught the bottom edge, and it reset. So I'll just restart. I've done as much as I can to deal with these parts that are really, really bad. Like I said, I got away with a lot more than we did initially. You know, the failure rate was, you know, every 3 or 4 parts we get a fail. So these improvements helped a lot, but still it's not perfect, because as long as the parts have that, that's what we're going to be dealing with. Again, that part got held up to the part behind it. Caught that flashing edge, and that's why that one got stuck. Let me just walk around the back here and show you the controls real quick. So I've got the cover off, a few wires not tucked in yet, but pretty well all set to go, just a little bit of finishing up. So what we're using, this is the Controlino processor right over here that does the pulsing for the vibratory feeders. We've got a PLC right over here, Panasonic. That's what does all the control work as far as the valves, the blow-offs, all the logic is done right there. Power supply, these are the solid-state relays that operate each one of the feeders, and they're controlled by the pulses from the Controlino and the logic from the PLC. These are your speed pots for the cap, the needle feeder, and the grommet feeder. And you're really not going to have to mess with them. They're just regular pots to speed them up, slow them down. The one on the left is your frequency. The one on the right is your power. What that's actually controlling is the pulse width of the frequency. And so we set the frequencies up to work with these particular feeders. There's some range of adjustment, but it's really not necessary. Once you hit the spot, you get them in the right spot, it's something you really don't have to move around. So you have your cap, your needle, and your grommet. And then here's the HMI. Pretty basic, just this selects if you want to run it in automatic or stop it. And this gives you all the manual operations. I know it's a little hard to see with the camera. Let me go off to the side here. But you can operate everything independently. You know, like run the cap feeder, excuse me, run the needle feeder, operate the lifts. Very useful in setting things up and getting things lined up. But most of the time, just going to put it in automatic and let it run. When the needle's in position, a signal will go out to your robot through these wires here. It's just a simple connection. You've got two wires out right over here. They're connected, but they're not tied up yet. But we'll have them all labeled for you. So one of them will tell you that the part is in position. The other one will be an input from you to us, to our feeder, telling it to go ahead and run. And you'll also have an input to us that tells it to turn the flex feeder for the grommet on and off. So that's pretty much it. You'll have one airline coming in. We keep the pressure around 60 psi, because there's nothing too big there that needs, you know, that high pressure. By keeping the pressure lower, obviously we're protecting things, keeping them from crashing. This is an air relief for the pusher cylinder. It's just the flow control. We leave it pretty much wide open. What that does is when that pusher cylinder goes forward, it makes it so that it doesn't have any power. So it's easily held back by hand, and if there is a jam, if something gets in the way, then it's not going to hurt anything, doesn't do any damage. That pusher cylinder, you loosen these two screws up, it's adjustable back and forth, and it'll move up and forward just by loosening these two. Once you get in position, tighten it back up. The feeders themselves, they sit on rubber feet, and they're retained by, see the retainer rings? There's two on each, so you can pretty much line them up. They'll stay pretty much where they are, but when you first get this, you're going to have to make sure that you're in line here. So, you know, you can move these feeders because they're rubber feet, move them over a little bit, but once you set them, you can lock them tighter with the rings and they'll be in good position. So that's going to be a critical part when you first get the machine to line it up. And like I said, here's your fiber optic sensors. So you have one that looks that the part is in position. It's a through scan. You have one that looks at the hole in the part. And then you have one that tells it that the cap is in place. That comes up from underneath. See it right there? Then the other one is the one that checks for the hole. So you got three proxies. One for the tell it the cap's in place, one to make sure the hole is there, and one to tell you that the part, so when the part is sitting in the nest, it blocks, your robot will get the signal, and that's our signal out to you that the part is there. Once you pick it, the system just restarts. So that's it. I'll send you this video. Give me a call if you have any questions, or if you'd like to see something different. I can sort out all those caps and just leave good ones in there, and we could take a look at that too. And I'm very, very confident that if your caps are 100%, you would have probably 0 jams. So anyway, let me get this going for you.